Today we are working on a 2008 Lincoln MKZ. We are going to be looking at the spark plugs and the ignition coils. As you can see, I already have the ignition coils and the spark plugs pulled out, so we are going to go examine the spark plugs. And then just looking at the spark plug and then the gap on each of these. Alrighty, we are looking at the wiring diagram for the 2008 Lincoln MKZ. Right now we are looking at our ignition coils, and we do have a coil on plug system. This is a V6 engine, as seen in the previous clip. I only showed the front bank, which are going to be these left valve cover coil on plug. I only showed the front bank taking out of these injectors, just because the other one's hidden by the intake manifold and it was a little bit harder to get to. But as you can see, all of the injectors share a 12-volt power supply, which is going to be this white and blue wire, even going to the ones on the second bank. But for the first bank, they all share a 12-volt system, which is going to come from, I believe, our battery. Yeah, so the battery junction box, so that's where our 12-volt supply is coming from. And since this is a two-wire system, our control wire is going to be our ground wire, where even as we ground each injector, each coil, it'll send a code to the PCM where it's pulse modulated, so the PCM will be able to receive the signal and ground it based on whatever load or RPM the engine is going through. It'll be able to recognize and read that through the ground wire, which, as you can see, the ground wire is going to be our violet and brown, our white and brown, and then our green and violet, which we will go see in 1 second. Alrighty, so as you see, when we were just talking about the coil on plug system for the MKZ, it also is a two-wire system. I don't know if you remember, but we talked about it had a green, it had a brown and white, and then it should have a violet, and then the power is going to be I believe it was black and white or brown and white. I'll correct that. I'll show you. I have a little text box to make sure that's correct in the video. But we are just about to measure the voltage at idle, key on, engine off, and then key on, engine on, and then we'll get some more pico readings in just 1 second. Alrighty, so right now we are back probe into our control wire, our ground wire, which will get grounded through the PCM. Right now we have key off, engine off is sitting at 0 volts. And as I'm about to go start the car. So we're gonna do key on, but engine off. So as you see, key on, engine off. We're gonna go back and look at those readings. So right now we are getting 11 volts, key on, engine off, which is pretty normal. The only reason we're not receiving full voltage is because the PCM hasn't fully grounded the coil because the engine isn't on. So as we cut this engine on, we will come back and we will see if that voltage increases. Alrighty. So now with the key on, engine running, yep, we are getting about 13.9 volts, which I would say is pretty consistent for idling, because the PCM has now fully grounded our control side, or our ground wire, with the 12-volt reference we've been getting from our battery. Alright, so I got my pico scope hooked up to one of the ignition coil's control wires. This is a two-wire coil, so one side is going to have 12 volts, while the other side is a PCM control or ground side. The flat line we're going to be looking at right here, that is going to be about 11 to 12 volts. That's just the coil hasn't been powered to ground yet. It's waiting until it has its next firing for that coil. As we come over to this drop is going to be our dwell period. That just means the PCM is going to ground the circuit. And the current is going to start to build up through our primary windings. as we get this spike right here, the PCM is going to open the current, collapsing the magnetic field, creating a high voltage induction spike. This is when the spark will actually fire in the plugs. And then these small bounces afterward, these are all oscillations. These are just leftover energy. And then this is going to be another flat line or our return line. The PCM is going to leave the current open again until it's time for the next firing.
Reference, and as we dip down, this is going into the dwell, and the dwell is going to be that period where we're going to have some buildup, and then we're going to explode up, and then as we're coming down from that explosion, this is going to be our burn time. Right here, you see that there's two kind of explosions happening all at the same time. But when this car is at idle, the ignition is splitting and firing off twice, but as it increases, you're going to see that it completely turns back into one. Yep. There we go. So right there, and that's probably just some issue the manufacturers had with this car where it just ran better with it firing 2 times during idle versus